Here we have the 3.B.1 homework, 3.128, 3.131, and 3.132. Starting at the top with the platinum chlorine compounds. We have two platinum chlorides that we need to find the formula for. So we're going to do our classic percent to mass, mass to moles, divide by smallest, multiply to whole. Doing the math on the first one, I get PtCl2, and then working through the steps on the second one, PtCl4. And you can see the steps that I did on 3.128. 3.131 is a bit different. In this particular example, you start with barium chloride, and it's a hydrated form of barium chloride. But then when you add sulfuric acid, it not only gets rid of the water, it also turns the barium chloride into barium sulfate. So we've got a little bit of work to do here to get to the formula of the barium chloride hydrate. I'm going to start by changing the grams of anhydrous barium sulfate. Anhydrous means without water. 1.864 grams of barium sulfate is what they tell us in the problem. Dividing by barium sulfate's molar mass, I get 0.00799 moles of barium sulfate. Recognizing that both barium sulfate and barium chloride have one barium atom, Ba and Ba, I come to the conclusion that for every barium sulfate there must have originally been one barium chloride. So we have this 1 mole to 1 mole barium sulfate barium chloride ratio. So that tells me that we must have originally had 0.00799 moles of barium chloride. Now, changing that to grams, I get 1.664 grams of barium chloride. Now, our original barium chloride with the hydrate, with the water in its formula, had a mass of 1.936. So if the barium chloride without water in its formula has a mass of 1.664, that means that we have 0.272 grams of water. Changing that to moles, I get 0.0151 moles of water. So now I have the moles of barium chloride, 0.00799, and the moles of water, 0.0151. So 0.0079 divided into 0.0151 is 1.89. Now I really wish that was closer to 2 than that, but we know that when you hydrate an ionic formula, you typically get a whole number of waters. And so I'm going to round quite a ways. I'm going to round 1.89 up to 2 so that I can write the formula BaCl2 dot 2 H2O. In other words, 2 waters for every 1 mole of barium chloride. Just looking for a whole number ratio there. Okay. Down below here we have the last question, which is a question about sulfur dioxide. Sulfur dioxide and forming from a volcano and turning into sulfuric acid. Now, the overall reaction would end up being 2 SO2s plus 2 waters plus 1 oxygen would make 2 H2SO4 if we wanted to know the overall reaction there. Now, they start me out by saying that we have 4 times 10 to the 5th tons of sulfur dioxide. Now, tons is not a metric unit, and it doesn't allow me to do the chemistry. And so I'm going to pretend that it's really not tons, but it's grams. Because I know how to change grams to moles. Tons to kilograms to tons to pounds to kilograms to grams. That's just a lot of steps that we really don't need to do because when we get to the end, we're going to change back to tons anyway. And so I'm going to go ahead and work the problem as if it were grams. Wink, wink. We really know it's tons, not grams. But we're going to work it in grams because it's just a matter of ratios and proportions anyway. So stay with me here. We've got 400,000 grams, 4 times 10 to the 5th, grams of SO2. Divide it by 64.06 grams, you get 6,244 moles of SO2. Now the sulfuric acid and the SO2 have a 2:2 ratio. So that's 6,244 moles of H2SO4 multiplied by 98.08 is 6.1 times 10 to the 5th grams of H2SO4. But here's where I'm going to go back and reinsert tons instead of grams, because if I had started with tons and converted back to tons in the end, this would actually be the number of tons. And so here's where I forget that I actually was doing this problem in grams and turned it back into tons.